Hello everyone, I hope you all are good and you all are practicing problems. Let us for now focus on this question. This is a question of refraction through plane and curved surface. So we are given one media of refractive index Ng, boundary of which is indicated over here. Ng value is equal to 3 by 2 and then there is one source of light kept at this point, and this point is at a distance of 3 centimeter from the front surface, and it is at a distance of 2 centimeter from this dotted optical axis. Okay. What else is given? We are provided with another plano-convex lens, of which one surface, one boundary is plane like this, another is curved, and its thickness is d. It is as much that you cannot neglect it, and then it has a refractive index of equal to 2 unit. Okay, so refractive index तुम्हारा 2 है. What we are said is the width of air gap between glass block and lens. So this is glass block and this is lens. Air gap is in between these two, and that gap is written as what? It is written as t. Now the width of air gap t and thickness of lens d is adjusted so that light paraxial rays from point source forms always a parallel beam after passing through the lens. So whatever paraxial rays are coming out of here after refraction, first through this surface, it will fall like this, then it will refract towards the normal into this media, and finally after coming out of the lens it will be parallel. Okay, so basically object is here, done hai, and final image is getting formed where? At infinity, because we are getting parallel range meaning they won't intersect in reality. I mean, we can assume that they are meeting somewhere at infinity. So this is the question. Now we need to approximate or exactly talk about the value of t and d. Okay, चलो काम करते हैं. सबसे पहले आप देखो, आपने यहाँ पे जो रे डायग्राम बनाया, सबसे पहले लाइट यहाँ से आई. पैरेक्सियल रेज मीनिंग रेज विच आर क्लोजर टू द ऑप्टिकल एक्सिस. ठीक है, so that is not making much angle with the optical axis. It is this. Okay, so यहाँ पे आप normal बना लो, and then light is going from glass to air. Light will refract this away from the normal, right? So, and after that it will fall over here. Let us first talk about this one. Where is the image getting formed? By refraction through the first surface. So if you extend it, you will get it somewhere here. So image is getting formed somewhere here. How we can calculate the value? This value. So how we can do that? I mean, you can simply use refraction through curved surface का formula. Though here is a planar surface, you can use real height, apparent height concept also. But यहाँ पे मैं curved surface का refraction का formula use करूँगी. So same I will use over here also. I mean, in this case, radius of curvature will become infinity. है ना? But we can use it. So let's say this side, if refractive index is n1, this side is refractive index n2, and these two sides of media are separated by a boundary which is curved. In that case, if object is over here, so incident light is in media n1 and refracted light is in media n2, done hai? Then we can relate object distance, let's say u, with the image distance, let's say somewhere here. So it is v. So v can be written as, I mean, n2 by v minus n1 by u is equal to n2 minus n1 by r. This is the curved surface, refraction through curved surface का formula. Then you must be aware of this thing. Okay. So यहाँ पे अगर आप solve करते हो, I mean r is infinity, so this term will become 0. Again, it is reducing to real and apparent height formula, right? So ये 0 हो जाएगा यहाँ पर, and N2 is the refractive index of media in which refracted light is. यहाँ पे देखो refracted light is in which media? In media air. So N2 value is 1, V we don't know, minus N1 is what? The media in which incident light is. So incident light is in media 3 by 2. इसका refractive index 3 by 2 है, and this is U. U is how much? I mean, object distance if you measure, you are measuring in the direction opposite to that of incident light direction, right? And you will measure object somewhere from this point, right? So, I mean, object distance आप यहाँ से कुछ ऐसे measure करोगे, so you are measuring in the negative direction, okay? So यहाँ पे आप लिखोगे -3 equal to 0. So 1 by v is equal to how much? 3 will get cancelled, minus minus plus, so minus half. ठीक है, so v equal to -2. So image is getting formed somewhere here. So image getting formed is somewhere here. ठीक है, if image getting formed is here, अब देखो यहाँ से जो light, I mean, if you talk about this in this structure, then you can see incident light on this media is directly coming from this uh, image. Image getting formed by the first surface. So this image getting formed by first surface will act as an object for the refraction through this second surface. Okay? So this will be acting as object. ठीक है तो एक काम करो let us draw it more closer. So somewhere here, let us now draw the incident light and it will refract towards the normal, right? Because refractive index of air is less than that of refractive index of this media, which is equal to 2. So light will refract towards the normal. Now where the image will get formed, again आप कहीं extend करोगे and you will be getting image somewhere. Okay, now let us talk about this calculation also. So again you will be using the same formula, done n2 by v minus n1 by u. So n2 by v minus n1 by u, and this is equal to how much? 0, because here also radius of curvature of this surface is how much? It is 0. ठीक है, so ऐसा कुछ लिखो आप. n2 is what? Refractive index of media in which refracted light is. So it is in media of refractive index 2, so 2 लिखो by v minus n1. n1 is what? Refractive index of media in which the incident light is. So incident light is actually this one, right? ये तो आपको extend करके ऐसे मिला है. So incident light is in air. So n1 will become 1 and u is how much? U कितना होगा देखो, this was 2 and this is t. So this will become minus of 2 plus t. Okay, done है? Minus of 2 plus t and this is equal to 0. Now minus minus plus 2 by v is equal to 1 by 2 plus t. So this is, sorry, with minus sign. So v is equal to how much? Minus of 2 and 2 plus t. So this is equal to minus 4 minus 2t. Done it? So minus sign indicates that image is getting formed somewhere to the left side of the surface. So let's say it is over here. Let's say it is over here. Done it? Now this light will fall on this surface and then refract uh, away parallel to the principal axis, parallel to this optical axis. ठीक है, ये parallel बनाना है. Done it? So now what will happen? Now refraction will occur through the last surface, that is this surface. And on this surface, light seems like it is coming from somewhere here. Okay? So basically, the actually rest the portion are simply something that you have extended backward, and this is the real light. Done it? So this is this, and after refraction through the curved surface, it will go like this. Okay, so if you write the same equation for this surface, that is what? N2 by V minus N1 by U is equal to N2 minus N1 by R. Now, in which media is the incident light? So you can clearly see here, incident light is in the media of refractive index NP. So here N1 is equal to 2 and refracted light is in which media? It is in air. So this is 1. Okay, what is U? So U तुम्हारा कितना आया था देखो, -4 -2t. It is from this surface, right? So for this surface, object distance will be where? It will be this one. So up to this point, it is -4 -2t and this will become d. So minus sign indicates simply sign convention that it is to the left of the surface. So if you calculate here the object distance, you will be writing it is 4 plus 2t plus d, right? Because 4 plus 2t is up to this thing, up to this one, right? It is 4 plus 2t plus d will give us the object distance. So object distance is this much. ठीक है, with proper sign convention we will be using it. अब देखो n2 का वैल्यू आप पुट कर दो by v minus n1. n1 is how much? That is 2. ठीक है, u I mean uh, object distance is object distance you will measure in this direction, right? And this is opposite to the direction of incident light on this surface. So object distance we will take as negative 4 plus 2t plus d. Okay, and this is equal to how much? N2 minus n1. So 1 minus 2, 1 minus 2 by r. अब देखो r इस surface का center must be somewhere here. So radius of curvature we will measure in this direction, which is opposite to the direction of incident light. So we will write here minus of 15. ठीक है. सो दिस इज -1/-15, सो दिस विल बिकम प्लस. अब आप देखो यहाँ से आप v निकालने की कोशिश करो. सो आई मीन v तो हमें ऑलरेडी पता है ना. दिस लाइट इज गेटिंग पैरेलल आफ्टर रिफ्रैक्शन, सो v इक्वल टू इंफिनिटी. सो 1/infinity you will be putting here, this will become 0. Okay, so -2/- of this. अब आप इसको केयरफुली लिख लो. सो माइनस माइनस कैंसिल हो जाएगा. 2/4 प्लस 2t प्लस d इज इक्वल टू 1/15. ठीक है. सो दिस इज 30. 30 इज इक्वल टू 4 प्लस 2t प्लस d, एंड दिस विल गिव यू हाउ मच? 26 इक्वल टू 2t प्लस d, and so 2t plus d is equal to 26. Now let us move to the options. So हमें क्या मिला है? 26 is equal to 2t plus d. Now let us check. For d equal to 16 centimeter, so if d is 16 centimeter, 2t will become 10, and in that case t will become 5 centimeter. Yes, it is possible. For thickness d equal to 10 centimeter, so make d 10 centimeter, this will become 16, and 16 by 2 will become 8. So air gap will be 8 centimeter. Yes, it also seems correct. The maximum adjustable value of d is what? So what can be the maximum adjustable value? अब आप देखो d का maximum value क्या हो सकता है? So d को आप maximum यहाँ तक adjust कर सकते हो, right? यानी कि maximum you can make t equal to 0. Done है. So maximum adjustable value of d is how much? It is 26 centimeter. क्योंकि यहाँ से अगर आपको d का maximum value निकालना है, how much it will be? It will be I mean t को 0 करोगे आप, 26 होगा. The maximum adjustable value of d is 16 centimeter. No. डन है. Similarly, क्योंकि क्वेश्चन में हमसे ये कहा गया है we can adjust t and d. So we can adjust to the long. We are getting 26 is equal to 2t plus d, because that will make sure that this light coming out of the curved surface finally is parallel to the optical axis. Okay. So I hope you have understood this question, but if you have doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.